Between 2021 and 2025, the global technology sector engaged in a capital allocation frenzy. The operating thesis was absolute. Injecting massive volumes of data into neural network infrastructure would result in the linear scaling of artificial intelligence. This chart shows the projected 2024 to 2026 global AI capital expenditure, the raw money spent on physical infrastructure, escalating towards $600 billion, plotted against enterprise AI software revenue flatlining near $100 billion. Capital expenditure, or CapEx, refers to the funds a company uses to acquire and upgrade physical assets like servers and silicon chips. To understand why revenue stalled, we look at the buyers. An audit by the National Bureau of Economic Research found that confronted with those internal metrics, executive satisfaction plummeted. Corporations aggressively cut their speculative software budgets and redirected funds into strict, pragmatic audits of their existing operations. The $400 billion speculative bubble was entirely unmoored from business fundamentals, marking a period where capital expenditure bore no relation to realized profit. Until early 2026, the entire financial architecture of the sector relied on NVIDIA. They operated as the absolute, uncontested gatekeeper of the hardware required to compute intelligence. In January 2026, the Chinese startup DeepSeek released their R1 model, a development that invalidated the existing Western paradigm of brute force hardware scaling. American laboratories required budgets exceeding $100 million to produce comparable reasoning logic. DeepSeek achieved it with a training budget of exactly $5.6 million. Blocked by American geopolitics from acquiring the latest chips, the startup bypassed the hardware bottleneck entirely. They deployed highly aggressive software optimization over an aging, restricted cluster of H800 processors to rival the output of 10,000 state-of-the-art units. The capital markets recalculated instantly. In a single intraday trading session, $589 billion evaporated from NVIDIA's market capitalization, dragging vast sections of the Nasdaq down with it. The barrier to hyperintelligence had fallen. By proving that brilliant software could bypass physical silicon, DeepSeek rendered the West's multi-billion-dollar brute force infrastructure obsolete. The financial correction was a symptom of a much harder physical limit. Computing cannot outrun thermodynamics, specifically the massive leap in thermal design power. Thermal design power, or TDP, dictates the absolute maximum heat a chip generates under heavy load. This 3D model tracks thermal load. Previous hardware required 700 watts per plate. The succeeding architecture doubled that to 1,400 watts. Stacked together, energy density broke civil engineering standards. Groupings historically drawing 20 kilowatts exploded to over 135 kilowatts, forcing $500,000 retrofits per megawatt. The first law of thermodynamics guarantees that every one of those megawatts converts directly into residual heat. Air conditioning fails at this density. Data centers adopted direct liquid cooling, which transfers the burden to massive evaporative cooling towers. A standard 100-megawatt installation evaporates roughly 2 million liters of purified water every single day of operation. Local governments reacted to the drain on municipal resources. Across the United States and the European Union, legislators initiated strict water usage metrics and enacted zoning blockades to halt new server construction. The demand for infinite scale collided with the finite realities of regional electrical grids and terrestrial water tables. While the hardware melted, the software ran out of fuel. Researchers accurately predicted that by early 2026, tech companies would completely exhaust the internet's supply of high-quality, authentic human text. Desperate to maintain their growth curves, laboratories pivoted. They began feeding their massive networks with synthetic data, information generated by previous iterations of artificial intelligence. This standard Gaussian distribution curve maps human data, with anomalies and rare creative ideas resting far out in the long tails. Relying on synthetic data causes model collapse, driven by the central limit theorem. Neural networks optimize for probable patterns. When an AI trains on the output of another AI, it aggressively discards edge cases, nuance, and rare representations. In just 5 generations of this synthetic loop, the system suffers late-stage collapse. The network loses real-world variance, producing only homogeneous, repetitive outputs. Developers tried adding tens of billions of parameters to force performance, but this only resulted in models that aced standardized multiple-choice tests while severely stagnating in actual corporate workflows. By feeding the machines their own output, the industry proved mathematically that intelligence cannot be generated in a closed, entropic loop. Survival required a drastic pivot away from monolithic models. Pragmatic engineers abandoned the pursuit of absolute scale and embraced strict mathematical scarcity. They utilized architectures like the mixture of experts, or MOE. Instead of a dense network where every node fires indiscriminately, an MOE system uses a dynamic gateway that wakes up only the specific nodes required. DeepSeek stored a total of 671 billion parameters, but the gateway activated only 37 billion parameters per task. This extreme sparsity delivered fast answers with a fraction of the electrical cost. The second technique, multi-head latent attention, tackled the KV cache bottleneck. It slices and compresses memory matrices down to 5% of their original volume. Stripped of bloat, these models no longer required industrial server farms. They could run natively on cheap, low-tier commercial hardware. This surgical engineering collapsed the cost of API tokens worldwide. The massive, expensive American cloud infrastructure was suddenly forced to compete with models offering equal reasoning logic for pennies. This transition from theoretical potential to audited efficiency mirrored a simultaneous fracture in physical manufacturing. The broader market violently rejected speculative futurism. In the first half of 2025, Chinese automaker BYD flooded the global market with tangible, affordable vehicles, reaching $51.9 billion in revenue. They sacrificed short-term margins for absolute utilitarian dominance. In direct competition, Tesla recorded a brutal 89% contraction in its free cash flow over a critical period. Their theoretical tech valuations fractured under the weight of foreign, commoditized manufacturing. Risk analysts trace clear patterns here. The previous decade saw conglomerates like Ike Batista's EBX Group built massive valuations on the promise of undrilled oil reserves, only to collapse when physical extraction failed to materialize. A valuation sustained by promises of planetary colonization and fully autonomous robotaxis operates on the exact same leverage of faith. Capital markets ultimately ruthlessly punish speculative holding ecosystems when confronted with competitors producing cheaper, tangible goods today. The corporate AI sector absorbed this lesson and decentralized. Massive volumes of critical business data abandoned the generic, centralized American cloud hubs and migrated outward to the edge of the network. Small language models, or SLMs, became the engineering standard. Clocking in between 3 to 12 billion parameters, these highly polished, task-specific models fit perfectly inside the 16 gigabytes of memory found on a standard corporate laptop. Running logic locally solved the enterprise bottleneck. It dropped query latency down to 50 milliseconds. More importantly, it guaranteed flawless compliance with the GDPR, Europe's strict data privacy law, and HIPAA, the American mandate for shielding medical records. Out of this ecosystem grew micro-SaaS, small, independent software-as-a-service startups. Instead of trying to invent a digital god, these founders built highly opinionated software designed to do exactly one boring thing perfectly, like auditing construction invoices or monitoring medical tax compliance. The 2026 AI winter matured the industry into a thermodynamically viable and ruthlessly efficient pillar of modern enterprise, shedding its reliance on speculative futurism for the reality of the balance sheet.